Assalamualaikum warahmatullahi wabarakatuh and good day. Today we will continue our lecture on chapter 5 numerical integration. In our previous video before the semester break, we have discussed one method in numerical integration where we call that method trapezoidal rule. In that method, in the trapezoidal rule, the method is used the linear interpolation to approximate fx, and then after that we derive a formula for trapezoidal rule to integrate a function of fx. And now, with the continuation of the trapezoidal rule, we want to discuss what is 1/3 Simpson rule. Because it is a continuation, so meaning that it has the same idea. Instead of using linear interpolation to approximate our function fx, now in this Simpson rule, we use quadratic interpolation p2x, or we call it the polynomial order 2 to approximate our fx. And then after that, we derive the formula, and then we can integrate our function fx. And this is the idea where the Simpson rule formula comes from. And if you can see here, you can recall what you have learned before, which is about Newton's forward difference of polynomial order 2, where now we want to approximate our function. And then after that, if you substitute in our function fx by using this Newton forward difference polynomial of degree 2, and if you integrate and if you manipulate, and then what you will get is the last formula here, h over 3 multiplied by f0 plus 4 multiplied by f1 plus f2. And therefore we say that in the 1/3 Simpson rule, to integrate of fx with respect to x from a to b, and we can use this formula where the formula actually comes from the Newton forward difference of polynomial degree 2. And then we just apply. So you can try by yourself how to prove this formula to get for your exercise. And I think in our previous video also, I've showed to you how can we obtain the same formula by using Lagrange interpolation. And then you also can try by using Lagrange interpolation of order 2 to derive the Simpson rule also. So once we have this formula, and then we want to look at it, or we want to apply it at the graphical figure here. So now let's say we have a function y is equal to fx, and at the first we don't know what is function, what kind of function this graph, and then the first thing we can interpolate this function by using the method you already know, Lagrange interpolation or Newton forward difference. And then after that, you can approximate what is the area under the graph. And by using the Simpson 1/3 Simpson rule, and then we can know the area under the graph. And because of the Simpson rule is a quadratic interpolation, based on the quadratic interpolation, and therefore for this interval from A to B, let's say now we divide it into 6 sub-intervals, and then by using Simpson rule, we only need to know 3 kind of area because of we using the quadratic. So meaning that we have this graph, okay, one quadratic, and then another one is at the area one. So we have this, the red one that I draw for you. So this is for the area 2, and then for the area 3 we also have a quadratic graph. We have a quadratic graph, and then when we integrate, and then we can do at 3 area, we can divide at 3 area, and therefore instead of using 6 sub-interval, and then now we reduce it to 3 area, and then we sum, and then we will get what is the area under the graph. And if you can see here, or if you can see in the picture, there is some part that is it is out, or it is out, okay, at this point. For example, that I shaded in blue, it is out from the our area. Sorry, it is not considered in our quadratic formula. And also here is another one at A1. We have this one, we have that one also, it is not considered. And at area 2 we also have this one, it is not considered. And at the area 2 also we have extra, some extra here, and at A1 we also have some extra here, because actually this is not in the area under the graph. So this is the some disadvantage about numerical method, because we have some kind of error. But in real one, actually we cannot do it analytically, and that's how we need some good method to apply our integration in order to get the area, for example the area under this graph. And then after that, once we interpolate our function, and then you can know what is the area under our graph. And here now, and therefore we want to integrate fx. Okay, we want to know what is the area of fx, the area under the graph from A to B. And then by using Simpson rule, we divide it by 3 big area, so that we have let's say now from x0 to x2 we have A1, so meaning here is area 1, and then we have A2, and then we have area 3. And then for each area we use, or we apply the Simpson rule, and this is the first one, Simpson rule. And then the next is the second Simpson rule to integrate from x2 to x4, and then the last one is the Simpson rule, one-third Simpson rule, to integrate from x4 to x6, and then we sum up together, and we will get the area under the graph. And by using like this, by doing like this, what we will have is the composite one-third Simpson rule. And if you see here, this is the first term here, it always start for f0 and plus the last one, okay, meaning that it is at the boundary at f0 plus f6, and then the second one plus 4 multiplied by the summation of, you see here, 1, 3 and 5, so meaning that it is the odd one, and plus 2 multiplied by the summation of 2, f2 plus f4, meaning that it is the last term, it is for the even. And then after this, no matter how many sub interval we will have, and this is a kind of formula that we want to use it. Okay, let's say now we have a 10 sub interval, so that the first term is f0 plus f10, and then plus 4 multiplied by the summation of the odd one, and then plus 2 multiply the summation of the even one, and then after that we calculate what is the value, and then we will get the answer. Oh, and in general, it is like this: h upon 3 multiplied by f0 plus fn plus 4 summation of odd plus 2 multiplied by the summation of even, where our h is from b minus a divided by n. And this is the formula in general, and now we want to apply it at example 2, where we want to evaluate our integral from 1 to 4 for fx. Here is sin x tan x divided by x cubed plus 3 with respect to x, and we want to use 1/3 Simpson rule with h is equal to 0.3. And for this example, the answer is given 1.1778, and we want to use 1/3 Simpson rule. I hope you still remember what is the Simpson rule, and therefore we need to use h is equal to 0.3, and therefore we will use the sub-interval is, let's say, n is equal to 4 minus 1 is divided by 0.3 is equal to 10. And our fx is equal to sin x tan x divided by x cubed plus 1. And because our 1/3 Simpson rule, actually it is h over 3 multiplied by f0 plus fn plus 4 multiplied by f1 plus f3 plus f5 plus dot 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 plus fn minus 1 for the odd one, and then plus 2 multiplied by f2 plus f4 plus dot 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 plus fn minus 2 for the even one. And therefore, to be systematic, what we can do is we can build a table. Okay, now we have I column. We start from 0, 1, 2, 3, 4 up to 10, because we need 10 sub interval. And then we have x also, xi. Our x is start from 1 with h 0.3, and therefore x1 is 1.3. We have 1.6, 1.9, and then we have 2.2, and then up to 4. And then the next column, I think it is better for us to have the summation of f naught and fn. Or in our case here, it is f10. And therefore, to calculate what is the value of f naught, we just substitute what is our x here to be 1 in our fx. Shine 1 multiplied by tanh 1 divided by 1 cube plus 1, and then what we will get is 0.4475. And then for this column, we want f naught and f10, and then we calculate the last value is f10. Again, you substitute what is the value of x is equal to 4, meaning that sine 4 tanh 4 divided by 4 cube plus 1, and what we will get is 0.4196. And then the next column is f for odd, so that you can calculate when x is equal to 1.3, and what we will have is 0.4578, and the next column is for f even. For even is x is equal to 1.6, meaning that we need to calculate sine 1.6 tanh 1.6 divided by 1.6 cube plus 1, and what we'll get is 0.4296. And last is the summation. For the summation here, I will continue in the next page. Okay, for the summation f, for this column, we only need f naught and f10. The summation, what we will got is 0.8671. And then we have 1.9637. And the last, or the summation for f even is 1.52. And then after that, integration, and therefore integration of 1 to 4 sine x tanh x divided by x cube plus 1 dx is equal to h over 3. Our h now is 0.3 divided by 3 multiplied by the summation of f naught plus f10, which is 0.8671, and then plus 4 multiplied by the summation of f odd, 4 multiplied by 1.9637 plus 2 multiplied by the summation of even, 1.5278. Then we calculate, and what we'll get is exactly the same, 1.1778. Exactly the same as the answer given. And this is how we apply the Simpson rule. It is same also for example 3 and 4. You can try to do by yourself. But if you can see, for this example 3, we are given, the answer is given for this integration. Okay. Integration from 0 to 1 for x divided by sed 1 plus x squared dx is equal to sed 2 minus 1. The question asks estimate the value of sed 2 using Simpson rule with h is equal to 0.1 for the above integration. From the question, we need to estimate what is the value of sed 2. Therefore, meaning that here, this value of SSCE2, each SSCE2 is equal to integration from 0 to 1 for fx. Our fx now is x divided by SSCE1 plus x squared dx, and then plus 1. And meaning that the one that we need to apply the Simpson rule is this integration. We need to evaluate. And then after that, we have the answer, and then plus 1. And of course, the answer SSCE2 is 1.4142, correct to 4 decimal places. It is the same value if you use calculator. But what we want to see is how you approximate this integration, how you evaluate this integration by using Simpson rule. And it is same also for example 4. You are given the table. Okay, everything is given for you. What is x, what is your fx, and now what you need to do is to evaluate x squared multiplied by fx. So meaning that this one, we will have the new, it is a new function, x squared multiplied by fx, meaning that let's say you can say it is a gx, and then you integrate gx. Okay, after you do some kind of step, and then you need to apply the Simpson rule, and the answer is given. That's all for now for Simpson rule, and we will continue in the next video.